Thanks for coming to this session. This is Getting Started with Amazon Aurora. It's an introductory session to help you get up to speed with the Aurora service. Just to get a feel, has anyone here actually used Aurora already? Okay, fair number. Okay, so what is Aurora? Aurora was designed to be a managed database that gives you the speed and the availability of a high-end commercial database while offering the simplicity and the cost-effectiveness and the lack of licensing lock-in of an open-source database like MySQL. Aurora is a fully MySQL 5.6 compatible database. It's designed to be a drop-in replacement for MySQL, so that we just want it to be easy for customers to get in and out of Aurora as they need. And Aurora offers the standard simple pay-as-you-go pricing model that you would expect from an AWS service. If you need it today, you use it, you pay for it. If you don't need it tomorrow, shut it down, you don't pay for it anymore. So why did we bother to build this? Why do we need another database service? Part of the reason was all those characteristics I mentioned. When we were looking at building Aurora, there wasn't really a viable option for doing that kind of thing on the cloud. Typical database architectures are relatively monolithic. I mean, you have a lot of functionality, SQL transactions, caching, logging, all kind of crammed into a single machine. And you can always buy a bigger machine if you need to scale your database, but that does get expensive quickly. You also have scale-out solutions where you can try and grow your database by adding more machines to the mix. Here are three fairly common ways of doing that. You can shard your database. That's one of the most common. Probably a lot of people here have done that. Where essentially you're moving your database across multiple machines and you're connecting them all at the application level. It can work pretty well, but it does have the downside that things that relational databases used to make easy can now become hard. Things like managing transactions across a large number of machines or running a complicated query that has to span a number of machines. All of that work has to be done by the application developer. You can try a shared nothing approach where you're essentially every node in the deployment, it owns its set of the data, and you connect them at the SQL levels. It's easier on the application developer. But if you lose a node, you lose the data. And so as you scale out across a larger number of machines, you start to get a higher availability and a durability risk with this approach. You can also try a shared disk approach, which is the kind of thing that Oracle RAC might do, where you're essentially fusing at the cache layer and giving all the nodes access to a shared underlying disk layer. And this can also work pretty well. Actually has a lot of scaling potential, and it's actually particularly good at things like load balancing. Since all the different nodes have access to the same data, you can spread your traffic out pretty well. But it has known scaling bottlenecks around things like there are hotkey or hot partition issues. There are also concerns around distributed locking. So when we were looking at building Aurora, we wanted to think about how would we design it in today's more modern cloud environment. The other scale-out solutions I mentioned, they work pretty well, and they were good designs for what they were designed for, which was you were probably going to be running your database on a pretty large set of machines that were probably sitting in a data center that you controlled. But today, we would probably expect to build a database system that certainly is scale-out, but also has a self-healing architecture, something that can recover from failures pretty well. And something that leverages a lot of modern cloud services that you can get with AWS that weren't available 30 years ago. So what we did with Aurora was we tried to take a more service-oriented approach. And rather than cramming everything into a single machine in terms of having every machine able to do SQL transactions, caching, logging, storage, we tried to look at each layer of the database and figure out, can we make this a more cloud-friendly layer? Can we separate it out from the main machine and leverage cloud services? So one of the most important things that we did with Aurora was we moved the logging and the storage layer out into its own multi-tenant scale-out storage system. It's a log-structured storage system that's really optimized for databases. And by moving the logging and the storage layer away from all of those database instance nodes, we're able to achieve a lot of availability and performance wins. We also integrated Aurora with a lot of other modern AWS services like EC2, VPC, DynamoDB, Simple Workflow, and so on. And certainly one of the most important is that we continuously back up Aurora to S3, which means that Aurora backups can benefit from S3's 11 nines of durability. So we announced Aurora in, I believe it was November of 2014, and then had a long beta and made it generally available in July of last year. And it's been quite humbling, actually, the response that we've gotten from our customers. So it's broken by a fair margin the growth records for fastest growing AWS service. And we've gotten pretty broad adoption across the AWS customer base. As an example, Expedia, probably a lot of you used it to get here. Expedia, if you don't know it, is just a massively popular travel site. You can book hotel rooms, flights, cars, things like that. And they had a SQL Server-based real-time business intelligence and analytics system, which was basically constantly looking at things like, how is the price of a hotel room tracking over time, minute by minute, and how is it likely to evolve in the future, which is pretty important for their business. They were concerned about the scale and the performance of that system, particularly with regards to the licensing costs associated with SQL Server. What they found was that they were able to actually reduce costs and improve performance when they switched to Aurora, and they were hitting on the order of 25,000 inserts per second on a typical day, but peaking up at 70,000, which was significantly better than what they needed. Now, it's not necessarily surprising that Aurora would have a cost advantage over, say, a commercial database, given the licensing fees involved. One of the emerging trends that we've seen in the last year is that for a lot of our customers, they're actually seeing lower costs when compared to open source databases, which was something that we'd really hoped they would be able to achieve. So 2 examples, Safe Software and Double Down Gaming. So they both migrated from MySQL. And Safe.com was actually able to reduce their bill by 40% and Double Down by 67%. And the reason that they were able to reduce their costs relative to even an open source engine is that Aurora was designed to significantly outperform MySQL. So here we have a quote from one of our customers, John Newton, who found a 10x improvement over MySQL. But essentially, when you have a database that can run a lot faster, you can run that database on smaller machines or on fewer machines. And so what we're seeing is a lot of our customers are actually taking a sharded MySQL deployment and collapsing it down into, in often cases, even just a single Aurora instance. And that's how they're leveraging Aurora to save money. But anyone can find an anecdote, right? So we should probably take a look at some more rigorous data on what performance really looks like. So these are some benchmarking results that we run. We actually run this test pretty rigorously. I get these results by email every day. We're running MySQL sysbench on our 3.8xl instances. So those are fairly beefy instances with 32 cores and 244 gigs of RAM. So this Aurora instance is able to achieve a little over 100,000 writes per second and 585,000 reads per second. So to put that in context, we pushed MySQL about as hard as we could on this machine, and this is about 5x higher than what we were able to achieve with MySQL. So we were pretty happy with these results. We actually wouldn't launch Aurora until we got to the level where we were this happy with the performance. But again, we also don't want to optimize for the one fancy benchmark that just makes us look good. You can find a way to tune any benchmark to make any database look good under some individual condition. But the other way that we like to look at it is we know that if someone's successful, their application's going to grow, things are going to change. And how is the performance of the database likely to vary as your application grows? So we looked at a couple of dimensions for how an application growth might change how the database works. So here's an example where we ran sysbench, but we varied the number of tables. So we started with 10 tables, and then we took it up 3 orders of magnitude to 10,000 tables just to see how the performance would vary. The line at the top is Aurora, and below are 3 flavors of MySQL, or 3 setups of MySQL. MySQL running on SSDs, MySQL on RAM disk, and MySQL running on RDS. So 2 observations here. One is that Aurora, as you would guess from the previous slide, pretty significantly outperformed MySQL. But importantly, as the number of tables grew, simulating the growth of the application using the database, Aurora held on to its performance better than MySQL did, which is by design. So essentially, if you look at I know that the dip is comparable in terms of absolute value, but if you look at the percentage drop in Aurora performance as you go from, say, 100 tables to 10,000, it's quite a bit smaller than the drop that you see in all 3 variants of MySQL. Another variation on this test is to vary the connection count. So, and this is something we see pretty commonly in production as well. An application becomes successful, the number of connections starts to grow very rapidly. We took it from 50 to 5,000, and we found that Aurora actually continued to improve all the way up to 5,000. MySQL improved significantly from 50 to 500 connections. Slight degradation going from 500 to 5,000, but not below where they started. So this is actually a good general tip for benchmarking Aurora and squeezing the most performance out of it. Aurora is pretty heavily optimized for a large connection count. So if you're running Aurora and you're doing a benchmark on a single thread, consider taking it up to, say, 1,000 and see how the performance varies. Another one we looked at was the dataset size. So here we started with a 1 gigabyte dataset, which fits very easily within memory, and we took it all the way up to 100. Again, same story as before. We had Aurora pretty significantly outperforming, actually got up to 67x better when we took it up to 100 gigabytes. And the gap, it's a little hard to see on this graph, but as the dataset size got bigger, the gap between Aurora and MySQL also got larger. So, as the product manager for Aurora, I often get asked, what is the performance of Aurora? Like, how does it compare to MySQL? And one of my favorite professors likes to say, the correct answer to any hard question is it depends. And here we ran 3 tests. We had one where it got up to 11x faster, one 8, one 67. What's the answer? It depends. What we strongly recommend is that you benchmark any database that you're planning to use. Run the comparison, and don't just try and squeeze the maximum that you can get out of any given machine, but think about how, for your particular workload, the characteristics of the workload are likely to vary. And then run tests across that range of usage characteristics, so you understand how, when your application gets 10 or 100 times bigger, how the database you've chosen is likely to behave. So how do we do this? At a high level, we try to do less work and be more efficient about it than other databases. Doing less work can mean less I/O traffic, in particular between the database instance and the underlying storage layer. And also sending less traffic across the network. We also try to be more efficient. So some of the things that MySQL will do synchronously, we can actually do in parallel, which gives us some advantage, both in terms of performance and also in terms of recovery time. Now, a lot of these, if you're interested, will actually be covered in pretty significant depth in a deep dive for Aurora session at 3:30 today, I believe. One I did want to call out in particular was fewer I/O. So this graph is showing you I/O traffic that occurs within the database for MySQL on the left and Aurora on the right. And this is what happens when you write into the database. With MySQL, when you write, there's a lot going on. You have to write to the log records, you have to write bin logs, you have to write to the data itself, you have to write into the double write buffer. And I should clarify that this is a multi-availability zone or multi-AZ setup in both cases. So we have two instances, each in different availability zones. So with MySQL, we have a lot of stuff going on there. And part of what we tried to do differently with Aurora was choose a back-end architecture that would reduce a lot of this. So with Aurora, you can see we have a significant amount of log records being written. So Aurora has a log-structured storage system, which is very heavily optimized for database workloads. So we actually have to write more log records than with MySQL, given the many copies of the data, which Puneet is going to talk about in a bit. But because we don't have to do the same level of traffic in terms of bin log replication, writing the full copy of the data, or writing it into the double write buffer, what we typically see is an order of magnitude reduction in the amount of I/O traffic for a given write compared with MySQL. Now, to talk a bit about availability and some other topics on Aurora, I'd like to invite Puneet Agarwal, who's a solutions architect with AWS, which means that he has a lot of experience building production scale systems with our customers.
Thanks, Dave. My name is Puneet Agarwal. I'm a solutions architect based in New York. So talking about Aurora, performance is indeed very good, right? 5x compared to MySQL. and in some cases better than that, depending on what you're looking at, number of tables, number of connections, so on and so forth. A lot of customers I work with are adopting Aurora just for that reason, right? Raw performance. But I think that's just one side of the story. On the other side, we see a lot of customers adopting Aurora because of its high availability features and its usability features. We have done quite a few innovations in Aurora that give you better availability than open source engines, but also better availability than some commercial engines. And that might come as a surprise. So let's take a look at some of those features. Let's say you're running a database in your own data center, and you want to make storage highly available. How would you do that? You would probably open another data center, do some replication on storage layer, or do some replication on database layer. You don't have to worry about all that in case of Aurora. In Aurora, storage is highly available by default. When you make an insert in the database, we make 6 copies of your data across 3 physically isolated data centers that we call availability zones. So you're inserting any data, it is getting replicated 6 times automatically. You don't have to provision new hardware in another data center. You don't have to do anything. So let's say if one disk fails or one data center failed, your database doesn't see an outage. You continue to be up and running at that time. Aurora also uses a latency-tolerant quorum system for reads and writes. And what that means is, let's say you're making a write. We use 4x6 quorum system for writes. As soon as your write makes it to the 4 disks out of 6 disks, we consider that write to be a stable write. So let's say out of 6 disks, if 2 of my disks are running slow, that doesn't slow down the whole database system, right? And if you were to do the same thing on-prem, you probably have one array of disks. If disks are running slow, that will slow down your whole database. So you don't have to worry about that in case of Aurora. With Aurora, you can also create up to 15 read replicas. And these read replicas will share the same storage as your primary server. So now, your read replicas can also work as a standby database. So you don't really need an ideal standby database for failover purposes. Your read replica will serve that purpose as well. Innovation on caching side. When we were looking at different layers of the databases and thinking about what layers to take out of the main process, caching was one of those layers. In case of Aurora, we separated the caching layer from the main database engine layer. And what that means is, if your database engine process crashes due to any reason, let's say a deadlock or some other issue, your cache process still remains there. So when your database engine process comes back up, your cache is still warm, and you can resume your fully loaded operations very fast, as compared to MySQL, where if the database engine crashes, it will crash the cache itself, and then you will have to run select queries to replenish that data. So that's, again, a big advantage with Aurora. Aurora also offers instant crash recovery. So in case of MySQL and many other databases, when your database crashes, the database will replay log in a single threaded operation. And depending on how many logs database needs to replay, your crash recovery can take a while. In case of Aurora, that's not the case. As soon as your database comes back up, we make database available to the user. And then we replay logs in the backend when you're accessing the data on demand. So that makes the crash recovery process itself instantaneous, parallel, and distributed. Let's take a look at how Aurora does in terms of failover times, right? So let's say you have a primary server running in one data center, one availability zone, and you have your standby server running in another availability zone or another data center. How much time would it take for our services to fail over your database from primary to the standby server? So let's do some comparison. Let's look at how it happens in case of RDS MySQL right now. For failure detection, it takes about 15 to 30 seconds. The next step is crash recovery, which we just learned can take unpredictable amount of time depending on the number of logs database needs to replay. In parallel, we are also propagating DNS from your primary server to your new master. That was your standby server. So overall, when these processes are done, your applications can then connect to the database and can resume operations. With Aurora, the failure detection time is, the process of it is similar to what we use with RDS MySQL. So your failure detection is still 15 to 30 seconds. And we are working on this piece specifically. We are trying to reduce the failure detection time to less than 5 seconds for genuine failures. So more to come on that. The next process is recovery process, which is instantaneous. And you can further cut down the DNS propagation time from primary to the standby using a special connection driver. And if you're using this connection driver, instead of waiting on DNS to fail over, this connection driver will query your database to find out who the new master is. So with this connection driver, your overall end-to-end failover time gets reduced to about 30 seconds, which is a huge improvement for an automated process and definitely huge improvement over manual process. And we hope to bring this time down, the failover time down to 10 seconds or under 10 seconds if we start doing faster failure detection. So one of our design intent with Aurora, like any other AWS service, was to make it really easy to use for our customers. Databases tend to be complex. There are many tasks that DBAs need to do in order to make sure your databases are up and running. So that was one of our design intent, to make it really easy to use for our customers. Mohammad Reza from United Nations shared with us that they especially like the monitoring dashboard of Aurora. It really helps them troubleshoot the issues, identify the issues much faster. So let's take a look at some of the usability features that come with Aurora. Let's talk about storage management, for example. Storage management in traditional databases is a tedious task, right? Most of the customers I work with, they are worried about their databases running out of storage. So what do? They over-allocate storage to their databases, right? Sometimes more than 50%, sometimes by 2x, 3x, and they end up paying more money for that. And I don't really blame them for this. I have done exactly the same thing as a DBA in my previous life. You know, I would request as much storage as I can get for my database. And we do that because we know adding storage to a live system will require manual intervention and may also impact availability and performance of my database. So why not just over-allocate storage? In case of Aurora, that's not the case. When you start an Aurora database, you are given a 10 gig chunk of storage, and you're just paying for 10 gig chunk at that time. But as your usage grows, we automatically add more 10 gig chunks of storage to your database on demand. So now in terms of storage management, you don't really have to do anything. The storage will automatically grow up to 64 terabytes, which is, by the way, another major feature of Aurora. It supports up to 64 terabytes of storage. And that is more than 10 times of what we support with other RDS engines. And 64 terabytes is a huge number, right? I mean, even if you're managing databases of 1 or 2 terabytes, that's a huge database. Most enterprise databases that we see average about 800, 900 gigabytes or 1 or 2 terabytes. Getting an OLTP system, 64 terabytes, that auto-scales up to 64 terabytes, that's a pretty beefy, very large OLTP relational database. Let's talk about backups. DBAs worry about backups also, right? In case of Aurora, your data is continuously getting backed up to S3. So you don't have to define a backup window. You don't have to run any custom scripts to take your database backups. Your data is continuously getting backed up to S3, and you don't see a performance impact. So finally, backups of large databases with no performance impact. And let's say you're a developer, you are releasing a new code in your database, you want to take a manual snapshot, you can just click a button, take a manual snapshot, and that snapshot itself is instantaneous because at that point, we're just putting a marker in S3. So imagine taking backup of multi-terabytes database in a second. That's really powerful for large database systems. And of course, no performance impact when you do that. Talking about monitoring, Aurora is integrated with Amazon CloudWatch, our monitoring system, and that gives you deep insights into what is going on into the system and the database at that time. So you can get access to CPU utilization, storage, memory, and 50 other OS-level metrics with 1 to 60 seconds of granularity. You also get access to database-level metrics. So for example, you want to look at number of database connections, replication lag, number of active transactions, selects per second, and many more. There are a lot of metrics on the database side that you can get access to using CloudWatch. And not only you can look at these metrics, but you can set up alarms on top of these metrics. So let's say you want to get paged when CPU goes above 80%, you can create an alarm in CloudWatch. You can do the same thing with any other metrics, number of database connections, cache hit ratio, anything. In terms of security, we understand security is really important for our customers, right? And that's why we have a very strong security posture around Aurora. Aurora offers full encryption at rest. So all the blocks that are sitting on the disks, all the blocks that are in S3 will get encrypted, and you can manage those encryption keys yourself using AWS key management system. If you wanted to encrypt your data in transit, you can connect to Aurora using SSL. In terms of network isolation, if you have used Amazon VPC before, you might know this. In terms of network isolation, all Aurora databases are available in VPC by default. So that gives you a lot of advantages in terms of security. You can use security groups, network ACLs, routing tables, private subnets, and all that to secure access to your database. So that's available by default. And since Aurora is offered as a managed service, there is no direct access to the nodes. You cannot SSH into your database box. You will connect to your database using a DNS endpoint and a port number, and that reduces your attack surface on the database itself. So I just mentioned Aurora is offered as a managed service, but what that really means. Aurora is offered as a database engine on our RDS platform, which stands for Relational Database Service. And if you haven't used RDS before, I'll give you a quick idea of what that service does. So let's say you have a database in your own data center. You are responsible for everything, right? You will procure the hardware. Somebody in your team will rack and stack it. Somebody will install the operating system. Database software will be responsible for patching. And then people will also be responsible for configuring high availability, scaling, database backups, so on and so forth. You, let's say, come to AWS and you start using EC2. You have an option of running your databases on EC2. You can install any database software you would like. And EC2 is our Linux and Windows-based virtual machines. If you're running your database on EC2, we take care of the data center portion of it, but you're still responsible for patching your OS, installing database software, and doing other DBA-related activities. But if you choose Amazon RDS, we take care of a lot of undifferentiated heavy lifting on your behalf. So everything that you see on the right-hand side is taken care of by the automated services in RDS, and that gives you a lot of time to focus on your application optimization, creating better indexes, creating better schema, tuning your queries, so on and so forth. I think one thing is important to remember that even though RDS is taking care of a lot of services, you still have full control over your database. Of course, you own your data, but you can also see and set up how your high availability looks like. You can still define what your backup window is. You can still define when you want your DB software patches to be applied. So you still retain that control. It's just that you don't have to manage it anymore. So Aurora is offered as a database engine on top of RDS. RDS also offers SQL Server, Oracle, Postgres, MariaDB, MySQL, and Aurora. So all the benefits you saw on the previous slide come out of the box with Aurora also. So no product description is complete without a discussion on its pricing. Does it make sense to use that product? Aurora is priced at 1/10 of the cost of commercial databases. So let's say if you're moving from a commercial database engine, you will save a lot of money by moving to Aurora. This is what Aurora's pricing looks like in our North Virginia region. As expected, there are no licenses to buy, there is no lock-in, and you pay only for what you use. So let's say you want to run some QA tests or some development tests on your system, and you're using your database for 10 hours, you just pay for 10 hours. That'll be like maybe $2 or $3, something like that. So you don't have to buy the system for the life of the system. You can just use it for the time being and just pay for it accordingly. But if you do decide to move your applications to Aurora, chances are your production applications will run 24/7. Your database will run 24/7. If that's the case, you can get significant discount over our on-demand prices. For example, if you do reserved instances for 1 year, you can get about 44% discount, and you can get around 63% discount over with 3-year reserved instances. And storage is also priced at consumption basis. So you don't really pay for a lot of storage. You pay for storage as you use the storage and as you do the IOPS on the storage. But I think Dave alluded to this before. And to a lot of our customers, it comes as a surprise that Aurora can save them money over RDS MySQL itself. Let's take an example, take a look at an example and see how that works. So this is an example of RDS MySQL configuration running in production. Very beefy database, 6 terabytes of storage with 10,000 PIOPS, so a very large enterprise database, of course. You have one primary server, you have a standby server for high availability, and you have 2 read replicas to scale your reads. This configuration in AWS on-demand pricing will cost you about $23.42 an hour. Let's see how this looks when we move the same system to Aurora. In Aurora, read replicas can work as your standby databases, right? So you don't really need an ideal standby database anymore. And storage is priced differently. Storage is priced on consumption basis. So your overall cost for the same type of box, R3 8 extra large, comes down to $18.35, which gives you about 21% savings over RDS MySQL. Let's take this one step further. Since Aurora offers you significantly more performance than RDS MySQL, you may decide to change the size of your instances from R3 8 extra large to R3 4 extra large. And if you do that, you save about 50% over RDS MySQL. So in terms of pricing, you would save a lot of money if you move from a commercial database system. I think that's pretty clear. But in certain scenarios, in production systems, you may also save a lot of money as compared to other open source database engines as well. And I think this is one of the reasons why we see a huge adoption of Aurora across the board. It's just a very good value proposition. So let's say, we talked about pricing, we talked about performance, high availability, so on and so forth. You like the new database, right? And you go back to your offices tomorrow, you want to give this database a test run. the first question you will ask yourself is, how do I move my data to Aurora? I already have my databases running in production. Since Aurora is MySQL compatible, migration to Aurora would look like migration to a MySQL database. If you're running on RDS MySQL right now, you can just take a snapshot of RDS MySQL database, automatically convert that database into Aurora, and that will happen smoothly. But we do realize that when you are migrating from other systems, on-prem systems, or EC2, or other database products, migration to another database platform can be a little difficult, can be challenging. So we introduced 2 companion services to help you with that. The first service is AWS Database Migration Service. I think it got announced last year and came out in GA 2 or 3 months ago. So with this service, you can start your first migration in less than 10 minutes. The service will connect to your source database. It will connect to your target database. It will do one-time data copy, but it will also do continuous replication from your source database to the target database. And that means you don't really have to take a downtime on your source database while your data is getting moved to the target database, right? Once your data has been completely moved, replicated to the target database, on a weekend you can take a couple of minutes of downtime and point your applications to the target database. So it supports continuous replication from source to target. This service also supports heterogeneous data movement. So if you wanted to move your data from Oracle or SQL Server to Aurora or Postgres or any other services supported by this tool, you can also do that. So that's a really powerful feature. And it will also do replication for heterogeneous databases as well. So this is just an example how this service works. It connects, you start this service, it creates an instance automatically in your VPC. It will connect to source and target database. You will select the tables and the schema that you want to migrate over, and it will fill your target database, and it will start continuous replication. A weekend comes, you can switch your applications to the new database. And of course, you will have to do migration testing, user acceptance testing, so on and so forth. So that doesn't change. So this was about moving data. But a challenge in heterogeneous database migrations is, how do you move your schema? How do you convert your schema from Oracle and SQL Server to a MySQL compliant schema? To help with that, we introduced AWS Schema Conversion Tool. It's a desktop-based tool. You can download this tool on your machines. It will, again, connect to your source database. It will connect to your target database. And it will automatically transform most of your schema to MySQL compliant schema. It does a lot of heavy lifting for you out of the box automatically. But there still will be cases where the tool cannot figure out how to convert your code into MySQL compliant schema, because in some cases, maybe MySQL or Aurora doesn't support that feature, right, that you're using in Oracle or SQL Server. So when that happens, this tool gives you a very detailed migration report. In this migration report, the tool will tell you things that it wasn't able to do, how critical those things are in terms of complexity, and it will also give you suggestions on what changes you need to make in order to transform this schema from source to destination. And there is a window there. You can edit your code there right away and apply it to your target database. Most customers I work with tell us that this tool is able to do 80% of the work for them automatically, and it gives them a very good idea of what the rest of 20% work looks like. So they know ahead of the time that how much time this database migration is going to take. With that, let me hand it over to Jeffrey Schmidt from Pearson. As you may know, Pearson Education is a leader in online assessment space. But what you may not know is Pearson Education did about 15 million assessments, scoring of computer-based tests on AWS infrastructure last year. Jeff is from Pearson's operations team, and he will share his experiences with Aurora with you. Thank you.
Hello, my name's Jeff Schmidt. I work at Pearson Education. We're based out of Iowa City. We're primarily a company that works on Java-based app stacks with MySQL backends, and we're in the online assessment industry, which is basically kids taking tests on computers. So our core business is basically built around kids taking tests on computers, largely kindergarten through 12th grade kids, and a lot of these kids are high stake, or a lot of these tests are pretty high stakes. They're the type of tests that you give a kid for, is this kid gonna graduate to the next grade or something like that. So, you know, they're pretty high stakes. The integrity of the data is paramount. And our platforms typically are composed of 3 different app and database stacks split out across all our different customers. So we'll have one app and database stack that's built around a website that teachers can load students and register students in the system and then start and stop the test sessions. We'll have another product that kids actually take tests on, and we'll have a back-end product that scores tests, generates reports, things of that nature. So three MySQL databases, 3 app stacks sitting in front of them, and then split out on a customer-by-customer basis. Just for context, for the background of our company and our MySQL usage, we've been pretty heavily invested in MySQL for about 5 years. We came from a Oracle stack before MySQL, and when we moved into Amazon, we kind of took that as our opportunity to get on a more open source tech stack, and MySQL is what we went with, and we re-architected a lot of our platforms to run on MySQL-based technologies instead of Oracle. So we first deployed our first line of products into Amazon in 2012, 2013, around there. At the time, you know, we did a lot of investigation into different ways to deploy MySQL. We looked at RDS at the time. We also looked at building them out on our own on EC2 instances, and ended up going with building it ourselves because RDS wasn't quite as good back then as it is now. So also in terms of scale, like, you know, we manage a lot of MySQL servers. I can't say exactly how many, but it's a lot, and the majority of them are on EC2 instances with a handful on RDS and Aurora right now. And as I mentioned earlier, we basically do separate MySQL servers on a per customer basis and a per environment basis. So if the customer is XYZ, they'll have, you know, a separate set of MySQL servers for dev, test, int, staging, production, and, you know, for however many customers we have, we'll have a separate set of MySQL servers for every single environment and customer combination. And finally, we've been using Aurora since day one of the Aurora beta. So, you know, we've been pretty in with the product since about November of 2014, and then when it went into beta, it was about January 2015. So, been in it since the beginning. So our database needs and priorities, ACID compliance is first and foremost, and of ACID, durability is the one that we care about the most. We're kind of a bank-style use case. You know, we can't lose any data. If a kid's entire future is dependent on getting a passing grade on a test, and then we lose 5 answers, that's a pretty big deal. So we focus on doing as much as we can to never lose any transaction that the application received confirmation of successful commit into the database. And from a high availability standpoint, if that means that we're down a little bit longer during a failover event or hardware failure or whatever, so be it. We'd rather be down for a couple minutes longer than to recover quickly but lose data along the way. And our performance needs just has to be fast enough. You know, we have such a large degree of environment and customer isolation that we're not trying to build one database that's going to do everything for everyone. So as long as it's fast enough for whatever the scope and scale of the customer and the application is, good enough. So we first started off going, you know, before Aurora existed, we had to find our own way on other MySQL deployment topologies. We tried them all out, used them all in various different production and non-production workloads. The first one, and probably the most popular one, would be just a typical MySQL master-slave topology, where you have one MySQL master database and n number of slave databases hanging off it. They are chained together using asynchronous replication, and if you do it right, you can fail over to a slave database in the event of a failure of the master. So things we like about it are that it's really simple, it's really well supported, documentation's good. Generally speaking, it's what everybody does in the MySQL world. But when you're at the scale that we're at, we've found that replication being asynchronous can be burdensome. It can lag behind. You can occasionally have replication just break for one reason or another, which has been quite a thorn in our side over the years. And from a failover perspective, we're always nervous to fail over to a slave, because if the slave isn't fully caught up with the master database, we could lose data during that failover, which again, in some of our products could be incredibly important, could be a really severe black eye to our customers. So we very rarely feel comfortable in failover scenarios in MySQL master-slave topologies. Something that gives us better high availability than master-slave topology is a Galera-based product line, something like XtraDB cluster from Kona, for example. These things work really well from a high availability standpoint, because they're all master, 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 and as long as you tell all your app servers of the existence of all these nodes, then they work how you would want them to. But it comes at a cost. There's a lot more servers that you have to manage. Wiring these things together is a pain, and performance of these things is not great. You're only as fast as your slowest server plus network latency when you're in a Galera cluster. And the serialized nature of the way the transactions are committed means that you really have to avoid large transactions, which isn't always feasible in every app stack. So, I'd say management, logistics, and performance make Galera-based technologies a little bit tedious. Third and probably most obvious to those of you at an Amazon conference is MySQL RDS. Not to be confused with Aurora, which is also on RDS. The pros of it are, pros and cons largely overlap with what you get from a MySQL master-slave topology, except you get the additional benefit of having Amazon manage the infrastructure for you and, generally speaking, do a lot of the heavy lifting so that you can focus on the data and the engine and that sort of thing. I mentioned earlier we tried out RDS 4 or 5 years ago. It was a lot more basic of a platform back then. It's a lot more up to date now. So it is a real contender for a company like us. But it still has the same basic problems that you have with MySQL master-slave. Plus, you're on Community Edition of MySQL, which does not have thread pooling, which as connection counts increase for apps opening and maintaining connections to the database server, connection count increases, performance generally tends to decrease on any version of MySQL Community Edition RDS fitting into that camp. And we also have data size limits in MySQL RDS. Granted, not a ton of use cases go up to or over 6 terabytes, but that's something you have to keep in mind as well. So that said, we've been kind of looking for something that's the best fit for us, that takes the best of all these other technologies and puts them together for us. And Aurora was a really good fit for us. Sorry, I forgot about this slide. We also took a look at a couple other MySQL deployment topologies, like using block level replication from the master database with a hot standby, or semi-sync replication. Didn't feel like doing it because it was just too far out of the mainstream MySQL use cases. So anyway, looking for a better solution than what we could do with Galera or MySQL master-slave, and Aurora came along. So why do we like Aurora? Failover with Aurora is pretty fast, all things considered, but more importantly, you don't lose data along the way. So whereas I was super afraid to pull the trigger on doing a failover with a master-slave topology, I don't have those same concerns on Aurora. and it fails over in 30 seconds, a minute, something like that. Whatever the time is, as long as it fails over and doesn't lose any data along the way, that's what I care about, and Aurora does that. Performance is at least as fast, if not faster, than on EC2 instances in our experience. Our workloads aren't necessarily the same workloads as some of the other customers that are doing like super rapid small inserts across broad spectrums of tables, that like the Expedia use case earlier. So for us, it's basically been as fast or faster than what we're used to, and that's been perfectly fine for us. Another nice benefit of it is that readers don't slow down the writer, whereas in a master-slave topology, you can have situations where a whole lot of readers connecting to a single writer, or a whole lot of slaves connecting to a single master, rather, can actually hurt the master, and that's a nice feature of Aurora, that it doesn't have that. And backwards compatibility with MySQL Community Edition 5.6 with Aurora means that if we find something about Aurora that we don't like, we can back out of it. We can go to Percona XtraDB. We can go over to MySQL Community Edition. We could theoretically go over to MariaDB. And we also have MySQL RDS that we could go over to as well. So we got options if something doesn't work out for us on Aurora for some reason. Then there's just the logistics of it. You get a lot of benefit from having all your infrastructure managed by Amazon with kind of the whole, you don't have to patch the operating system yourself and all that sort of thing. And the fact that you don't actually have to plan ahead for disk storage allocation is super convenient for us, because we're always, going, okay, we think we need X terabytes for this customer and X gigabytes for this other customer, and like whatever your projection is ends up being a little bit off, and you have to micromanage it. You don't really have to do that with Aurora, nor do you have to worry about babysitting traditional MySQL replication with Aurora to keep the readers running properly. They just work. That's great. So our experience with Aurora in production, non-production, has been pretty smooth, all things considered. Some things we've learned along the way that I thought might be beneficial to those of you that haven't used it before or just kind of cutting your teeth on it. There's for Java and Java-based technologies, there's a specific driver out there that's not the Oracle-provided MySQL Connector J driver. MariaDB provides a driver that has Aurora-specific functionality to it, specifically enhances failover capabilities. So we recommend using that over the MySQL the MySQL Connector J driver because of enhanced failover support. Next is you need to test your application before it hits production using Aurora. There are differences in how the engine for Aurora, and just general differences in Aurora that make it a good idea to at least hit Aurora with your application in some QA or performance environment or just some staging environment, something like that before you actually hit production. It's supposed to be completely drop-in compatible, but you never know. You might find something that's a rare edge case that breaks your application, and you want to make sure you find that before you go to production. We also recommend failing over regularly in your QA environment. The only way you can get confident with something like your application failing over all the time and not really ever knowing which one's the reader and the writer at any given time is by failing over regularly. So we do that in our environments, and that's given us a lot of confidence in our failover capabilities. The presenters before me also both talked a fair amount about the performance benefits of Aurora, and that's all true. But you also have to keep in mind that there's ways to get better performance out of Aurora, and you're still bound by the limitations of MySQL. So if you're running CPU-heavy queries against Aurora, they're still going to be slow on MySQL or traditional EC2 infrastructure. There's probably still going to be just about as slow on Aurora. You're not going to get incredibly better query performance if you're doing a 30-table join with 1 billion rows in every table. It's still going to suck. You have to still optimize your code. And when it comes to how you use the reader nodes, you really have to make sure that you're using the reader nodes for the things that they're best at, which in our opinion so far has been for big, heavy queries that you don't want running against the writer node. things that are CPU heavy. They may be asynchronous. They may be for analytics. They may be for reports. We've basically delegated the writer node to most small OLTP traffic, and the readers for failover and for reports and kind of heavier query use cases. Other advice that we have on performance front, if you can get away with not having binary logging turned on, don't turn it on. Aurora read replicas don't need it to work. The only reason you want binary logging turned on is if you're doing asynchronous replication to a MySQL server that is not an Aurora server. So if you want to replicate to an EC2 instance, or you want to replicate to a data center or something, turn binary logging on for that, and potentially replicate from Aurora into your data center infrastructure or whatever for data backup. But don't turn it on if you don't need it, because it will hurt performance. Also, leave query cache on. In regular MySQL, query cache is kind of oftentimes a performance poison pill. But in Aurora, it at worst does nothing for you, and at best helps you out a fair amount, at least in our experience. So we recommend leaving query cache on unless you have a reason to turn it off. And as I mentioned earlier, Aurora's not going to fix a bad query. So for the DBAs out there, you still have to tune your queries. That said, our experience with Aurora has been great. There's a couple things we also wish that it could do that it currently can't. Amongst other things, we wish it had smaller, cheaper instance types. Right now, it's limited to the R3 tier of instance types. We wish that we had smaller ones like T2s or whatever for our dev and test environments. Not the sort of stuff we run production with, but when you're building lots and lots of QA environments for different customers and use cases, you want smaller instance types. Then a couple other ones, like on the replicas, you can't set the transaction isolation level that's hard-coded to repeatable read. Kind of wish that it wasn't, but it's not a deal breaker for us. And we also wish that we could kind of earmark a replica to be a replica that is not a failover candidate. Right now, the replicas, they're all potential failover candidates. You can prioritize which ones you want to fail over to first and second and third, but there's still a chance that even your lowest priority replica could be failed over to, and we wish that there was a way to not do that. Yeah, I think I'm going to end it here so we can do a little Q&A. And thanks to everybody. It helps out our Pearson solutions architects, our technical account managers, all those guys. So, yep.